This is the first lab of the protocol development section. So that's very exciting for us because it's the first time we're doing this. And hopefully it'll be exciting for you guys. What we've decided to go with is we're going to start by developing a networking layer. And then next week we're going to develop a storage layer. The week after that, a cryptography and security layer. And why am I calling them layers? Well, what do you guys think? What are we layering here? Right, exactly. But are we building a cake? Yesterday was Pi Day, right? But no. So we're building our own blockchain, right? And so by the end of the semester, hopefully everybody should have a working, running implementation of a blockchain. But what does that mean? You know, you go online, you look at a GitHub repo, right? You type in blockchain, Python, whatever, and you see people who already have working implementations of blockchains. What's the difference between what we're going to be building and what those implementations are? Ours is better. Okay, subjective. So the difference is that many of the implementations you see online are simulated. What does that mean? That means that you can artificially mine the next block, and it contains all the correct, input fields and whatnot, or at least at a high level what the input fields should be. And maybe you can run a few tests on it, change the difficulty, and there are very good examples online that I can link later on. But what we're building in the coming weeks is going to be a blockchain that you can use to propagate blocks to fellow peers over a local network. So, basically if I start a Genesis block, everybody will be able to do work on that Genesis block, for example, and build the next block and propose new blocks. The fields that we're going to be inputting into every block will hopefully be accurate to the original Ethereum specification, which is usually not the case. And furthermore, we'll be securing our transmissions cryptographically such that they are safe against man-in-the-middle attacks. And yeah. Does that sound exciting to you guys? Is that something you're interested in?
Yeah.
Do you want to go back to doing smart contract development?
No.
All right. But just to recap as well, what you should, or hopefully should know by now, is all the intricacies of dApp development, a little bit about the stack, and a little bit about deployment. And now I leave it to you folks to approach us with any further questions you have on the dApp module. So learning is not really, you've hit a couple milestones, but it doesn't stop there, right? Learning is a continual process that you build on top of. And hopefully we've given you the tools to be able to learn more. We haven't given you the tools to be experts. Certainly not. I don't think any of us would call ourselves experts either. But hopefully you have the tools to progress on that end. Okay. Any questions about the past, the present, or the near future? Excellent. All right. So this is what we're going to do today. Hopefully we'll get through it really, really quickly and do an activity together at the end and hopefully adjourn early, or you're free to work on some dApp stuff, or you're free to work on some networking stuff. So freedom is there for you guys to decide. A refresher on networks a little bit. So this is just the most important stuff that we covered from last week. What is this? Everyone's mumbling. Shout it out. Centralized or decentralized?
Centralized.
Okay, cool. So this is a centralized server networking model, server client. What was the issue with this that we talked about? Single point of failure. Okay. What did we move on to after this? Does anybody remember? Did we move straight to a fully P2P network?
No.
So what did we talk about after this?
It's like a ledger.
Right, like an intermediary. So this is sort of P2P. What was an example we gave? Napster. Napster was a good example of this. And what was the issue with Napster? What ended up happening? Right, it was shut down. And so for whatever reason, legal or otherwise, it was shut down and it failed. So again, this was, again, a single point of failure. Right? Okay. Then we moved on to alternative P2P models. And these are strictly P2P, where you don't have a client-server model, but in fact, you have a client-client model, where everybody is a node, and everybody interacts with everybody else. And if somebody's too far to get to, they use other clients as intermediaries. So everybody helps each other out. Now, talking a little bit about P2P, how do you measure distance between two nodes? Miles? Meters? Kilometers? Time. Now, what do we call that? Latency. Yeah? If I ping somebody in the back, and then I ping Luke, and it takes me less time to reach Luke than somebody in the back, then obviously Luke is closer to me. Or generally. And that's the main idea. So here, if green client can't reach purple client, and purple client has what they're looking for, if we recall the example of Nadir and Bitcoin.jpg, where I think it was Philip who had it. Philip had the Bitcoin.jpg. What was the issue with this model? This was the MST model. I'll give you a hint. It's similar to the previous models.
Did you corrupt that file, or that person went down?
Yeah. So if the orange client up top goes down, then again, that's the single entry point to Philip is gone. Okay. So then we came to this example, and I left the labels on there just to kind of remind us what the whole thing with query and query hits and pings and pongs was. But so this is the ideal example, right? Where you sort of broadcast your query to all your peers around you, and then they'll broadcast it further, and then it'll just propagate outwards. Now there are two things we haven't talked about. One of them is the TTL. So every packet comes with time that it's just going to expire. It's just going to die. And why do you need that? Why does every packet need to expire after a little bit if it doesn't find the query that it's looking for?
Because there might not be a connection to possibly send the packet.
Okay. There may not be a connection, so you don't want it to just linger on a single node, right? But so the way packets work is that they die after X number of hops. What is a hop? So yeah, every time you move from a node to another node, that's a hop. So why do you want the packet to die after a certain number of hops?
Wouldn't it clutter up the network otherwise?
Exactly. So congestion, network congestion. You want it to propagate in such a way that it reaches most, if not all, the nodes on the network, but then you don't want it to bounce around back to nodes that it's already visited, and just continue in that system. Because if it never finds the file that it's looking for, then it'll just bounce around forever, right? And that's bad. Okay. Is everybody happy with this? Oh, one more thing. Can anyone tell me the difference between a unicast and a broadcast?
So I feel like it's based on what they're called. So like unicast, you have a specific person or node that you're contacting, but broadcast, you just send a message and looking for a response back.
Yeah, so you with a broadcast, you send a message to all the peers you're connected to, whereas unicast, you send it to one. Now, what's interesting is that there's something called a multicast, and I'll leave it to you folks to find out the difference between a multicast and a broadcast. And so broadcasts are generally how things like your routers work. So they'll be broadcasting messages to everybody on your network. for example. Very inefficient, but also effective in doing what you want. And so in this instance, not this specific one, but maybe in things like Nutella, again with the silent G, what do you guys think Nutella uses? Broadcast. Yeah, because that's what you want. You want it to get to as many people as possible, but then not clutter up the network. And there are various optimizations using distributed hash tables. I think Akash started talking about Kademlia last time, which is in fact what Ethereum uses. A more simple version, if you want to look into the way distributed hash tables are optimized, lookups are optimized, look into the progression from Cord to Kademlia. And actually, we'll provide some resources such that you may or may not be able to implement those things on the networking stuff you built today. Now, the near future, we started talking about this. You're going to be building your own blockchain for the people who just came in. This is very exciting. Somewhat, I think, unique to the models you'll find online. We'll not linger too much on this, but Akash started talking about the lookup and peer discovery mechanism, Kademlia. And why do we do this? What is this? It's a tree. What kind of tree? It's a binary tree, okay? And what does it represent? Forget the arrows and the thing up top. What does it represent? IDs, right? And what is it telling us? Like if I look at this, right, and I see that there's a black dot, right? So that's my query. That's the node I'm trying to reach. And relative to that node that I'm trying to reach, what is every other node on that tree? Like say, what is the difference if the node is here? And what is the difference if the node is there relative to the black node? There's someone in the back.
It's like the relative, it's like all the different paths you can get to the end.
Right, exactly. It's the relative paths you can take, which means that if the node shares an ID with a smaller Hamming distance than another node, then it's closer to that node, right? So this is a representation of distance, right, between different nodes. Now you could just say you could just send out a packet and hope it gets there eventually, but this is a way more optimized way of looking at things, right? Because now you know if you want to get to node 6, you know who you need to discover to get there. So say you're this node right there, you shouldn't propagate a packet over there, right? You should just propagate a packet over here somewhere. So there are things like K-buckets that you can look at. Again, we're not going to dive too deep into it. Just watch last week's lecture. That's what's called a distributed hash table. That's just a representation of that. RLP encoding, again, something Ethereum uses. Transport protocols. What were the two transport protocols that we talked about last week? TCP and UDP, right. And what was the difference between the two?
UDP is fire and forget, and TCP is like three-way nature.
Right. So TCP is a more secure way of transporting packets. You are assured that if you send something with TCP, it will continue to try and send the packet until it's received. Whereas UDP is, it may get there, it may not very reliable. Okay, and Ethereum uses TCP, and so you can look more into the transport protocol that it uses. Statistical multiplexing, encrypted handshake, all these things we're going to be building on a one-off basis. So like this week we're focusing on the networking side, maybe some peer discovery stuff, and hopefully that'll be a collaborative effort. If you guys spot a way in the docs that you think we can improve the protocols that we're using, feel free to suggest that. We talked about storage optimization that we'll be handling next week, and then in the following week after that, we're doing, what are we doing? Security. Awesome. Security and encryption. And so again, just to rehash, we're going to be building a blockchain that everybody on your local network will be able to see and interact with. All right. So why does dev P2P kind of suck? These are some interesting issues. The biggest one that you have to think about is upgrading the protocol. How do you upgrade a P2P protocol? How do you think? Okay, let's do this. How does a company do version control? Git, right? Git, they push to GitHub, somebody pulls from GitHub, and they have the new version. Good stuff, good stuff. Could you do that with P2P networks? Well, you could, right? You could just broadcast, hey guys, there's an update on the GitHub, if it's open source, download the new client. Okay, but does that work? Well, yeah, nobody is on the same page, right? Because it's not a centralized entity. Some people may say no. Some people may not see the message. Some people will disagree with the changes that you're proposing. And that's when you get a network fracture, right? Now the network works in two different protocols, right? And eventually things get different enough that they're two entirely different networks, or three, or four. And that's network splintering, right? And you can take that analogy and kind of talk about it in the context of blockchains for things like forks. It's kind of the reason we have things like Bitcoin and Bitcoin Cash. If anybody knows the conflict there. Yeah. Who follows Bitcoin, at Bitcoin on Twitter? Actually?
Yeah, but it's not really Bitcoin.
Nice, yeah. So, a little bit of trivia. If you follow at Bitcoin on Twitter, it's not really Bitcoin. It's the Bitcoin Cash representation. And they really like to push this notion that they are the original Bitcoin. And the Bitcoin Core team is entirely separate. So they call Bitcoin Bitcoin Core, and they call themselves Bitcoin. Very, very confusing for newcomers. No matter what side you pick, I think that's a little tidbit that is useful for anybody to know. And also, get on Twitter. It's a good time, especially in the crypto space. Very good time. Okay, so now we get to the assignment portion. I hope you guys have your laptops out. So this is the repo. But before that, I mean, if you caught that, that's fantastic. Oh, awesome, yes. Okay, so right now I have set up a server, and it's listening on a certain port, on a certain IP, and it's listening over this local network that we're connected to, AirBears, right, in this case, but you could do this over any local network, hopefully. It hasn't been tested on AirBears, so I hope this demo doesn't fail. I see Luke smiling because we've talked about this. But yeah, so it's listening. What is it listening for? Yeah, it's listening for your messages, right? And I mean, I could start up another client. Right. Okay. Perfect. So this is how it works, right? It sent a ping and got back a pong. Very cool. Very cool. And let's look at the server again. Awesome. Yeah. So it got a connection. It received a message ping, and it sent back a pong. So what we're going to try and do now is maybe get you guys to try and cast your message to the server. And so the GitHub is up. You guys can clone it, and you don't need the server because I've got the server set up. But launch the client, right? And try and see if you can send a message to me. And actually, just to spice things up, This is a competition. Whoever gets there first, congratulations. I don't know. Okay. So let me move this in the screen a little bit better. Yeah, is that better? Right. And how many people actually want to go through the code for this? Nobody wants to go through the code. 2 people in the front, 3 people, 4 people. Gustavo in the back. Wait, one more time. Okay. Do you guys think it'll be useful to win the competition if we go through the code? Hands up. Who thinks yes? Okay, that's like almost half. Hands up explicitly who thinks we should not go through the code. Okay, let's go through the code a little bit. In that case. Okay, sorry folks. It's turning off. Okay. Okay, so this is written in Python, right? Is everybody, okay.
Can you zoom in a bit?
Zoom in, yes. I can, does the color, do you think I need to change the color scheme a little bit? So if I do this, is that better? Is that better or worse? I'm not sure. Okay. Okay. In terms of design, I think white is more readable. So, okay, whatever. Okay, so who knows what this line does? Yeah, so it's checking if you have called it from the command line, right? And so this is, I think, if you think about like programming languages like C, it's the main function. Some people like having a main function in Python and then calling it under this script. It's whatever. You can do whatever you want. And so we're parsing some arguments. This is the way we interact with the command line. And here we're providing an option to enter a custom port. If you don't enter a custom port, it'll default to 1 through 3, 4, 5. So you can put in any port you want. Try not to use the ones that are meant to be used for other things, like 8080 and a couple other ones. Yeah, so just type in a random sequence of numbers. Okay, so this is where we set the default to be 1, 2, 3, 4, 5. IP is just my own localhost IP. And then we set up a socket, and then the socket listens, right? And that's a server. And the socket object is defined above, right? So it's instantiated. It takes note of a list of clients, the order in which they send messages, the files that are stored locally. And so this files array is not actually useful yet because you're going to be doing the storage next week. So whether the socket is online, what protocol it's following, UDP or TCP, and then the socket itself, you bind it to an IP and a port, and then we have just some error handling there as well. Everybody clear on the init? Who's confused so far? Okay, and I think it might be useful to actually leave this up for a little bit longer. Okay, who has not cloned the repo yet? Who needs more time? Okay, everybody's got it. Awesome. Okay, so the way listen works, and this is probably the most complex method, and then after that, everything should be intuitive. It asserts first that the socket is online, sets the message to just a few dots, the default message, and then it listens according to the limit. So it'll stop listening after 5 nodes have connected by default. We can change that. Prints listening. Accepts an incoming connection. Tells us that we've got an incoming connection and from the address that it's coming from. We grab that message we then process it and respond to it as well. And then we close that incoming connection. You have the option then to interrupt the listening process. That's just Control C. And this is handled. And what's important here is that the socket is closed before you exit. Because if you try to run the program again, what's the issue?
You have a program open in the background using the socket, so you can't re-access that because there's something already there.
Exactly. So if something is using like port 9999, you need to close it, which means that you have to PS and kill the process that's using that socket, that port, before you can instantiate another one. So this is just for convenience. And then the rest of the things are pretty intuitive. And it's somewhat similar on the client side as well. Similar setup. So the reason I'm going through this is because actually this is a server-client model. And it's going to be then your job, right, to implement a semi-P2P or P2P network if you want. This is just something we're doing for a little bit of fun. I understand that the assignments have been a little bit rough so far. We've been throwing a lot at you, and we want to remind you guys that this is just a decal. So it's time to have a little bit of fun, right? Okay, so now that we know what the code does, and we're all networking masters, who's ready to try this? Okay. Who's not ready to try this? Okay. I saw one hand over there. I hope.
Computer's broken.
Oh shoot. Okay. Feel free to partner up with anybody else. Okay. So we're listening, and then we're pinging. So the ping is the default message. If you want to set your own custom message, which I think you should, do it like this, right?
Says connection refused.
Yeah, but we're trying to connect to yours, or we're trying to connect to our own.
So you're meant to connect to, let's see, this. Oh. Try connecting to this with the port 9999.
So how do we specify that? Oh, we use 4999.
Yeah, so you specify port by doing a -P.
Yeah, it still says connection.
Yeah, I can connect to my own thing, but I can't connect to yours.
Interesting. Yeah, this was kind of something I was afraid of with Air Bears.
Can we try Cal Visitor?
Yeah. Okay, let's see.
Now I'm using Cal Visitor. Still.
Well, I'm not on Cal Visitor though. Yeah, so let me get on Cal Visitor. Okay, you know what? Everybody try and run it on their own server, and then we'll come back to this. I'm gonna leave it running just in case somebody does manage to connect. But let's try and figure this out. Okay. For people who want to connect, can you try this IP address instead?
Wait, what is?
Yeah. I can't hear you.
Yeah, what's the flag for the IP address?
Oh, yeah. So there is no flag for the IP address. You should replace, let's see, this thing right here. Oh, no. Hold on. You should replace, let's see. Yeah, you should actually replace that, I think.
We have to connect to AirBase.
So I'm connected to Cal Visitor.
Oh.
Yeah.
What is the IP again?
Oh.
Still port 999.
Yeah, still port 9999.
So if I'm already on port 9999, like server, what is that? Because I'm like getting messages for myself.
You're getting messages?
I'm doing client.py.
So that's your port 9999. Yeah.
How do I get to yours?
So it's the same way. Yeah. It's just a way for you to tell the packet once it arrives which port to look at, basically. Yeah.
And like multiple people can be on that port.
So I can be on my own port, and then your message will like find me, and then multiple people can find my port. Yeah.
Time's out still. Still time's out.
Still time's out. Okay, well.
It doesn't get refused though, it's just like time's out, it's like it doesn't get
Right now.
Yeah, so that's actually the same issue that Luke and I were having. We tried to connect to our school accounts, and then like try and interact that way, and we were getting the timeout error. So I do imagine it's a network thing. Try it at home then, and it should work because we did it and it worked at home just fine.
You can just specify that IP. Or do we just do dash 8999?
Yeah, so you do dash P999, but in the source code you should change this part.
You can change
Yeah, the client. So these, FYI, these clients and servers are yours now. You should just experiment with them. Try and send messages. Try and send things like text files.
What do we change?
Pictures, images. So what's highlighted?
What do we change it to?
To my IP address. Yeah, maybe I'll write it down actually on the board. Yeah, so it like changes over time. So. You got a pawn?
Yeah.
Yes. Okay, we have a winner, guys. Awesome. Let me just make sure. Oh wait, no.
You just change.
Wait, are you sure it's not just on your own?
It's on
Jump the gun. Jump the gun.
Wait, so
Mine's just like.
pass this as a string. It could be just a string.
Oh yeah.
I'm timing out right now. It's like
Yeah.
Wait, is it 142 now?
So no, that's from the client. Don't worry about that one.
Oh, so then what is
You should be paying attention to
10.105? Yeah,
Mine timed out.
explicit with this. Because right now I'm getting my own local IP, but I just do this.
You are on port 999.
Yeah. Okay, so that is the static IP right now.
The attempt for it too, and we're stuck on the same transaction. So what kind of object is the
So the response will always be the pong. But it'd be cool just to see your name up there.
something like
Yeah, I saw that. So do you want to try again right now with that IP address?
I actually just
It's still not working.
No, I didn't see it. I mean,
kind of thing. So if you're just like, I don't know if you can search with the file. Oh no, you can do it with this. You can just directly put in. Yeah, just like the JSON, just as a JSON object. So yeah.
No, you're not. You're not. You're not. You're not. You are. You're the end game guy.
That's so hard.
How are you guys
I'm using dash B.
is that yours and me?
What?
Did you get like a response? Or did you time out?
Yeah. Yeah.
Yeah, you have to change it like that.
You think Airbus is interfering?
I think, yeah.
It seems very late.
That was the only thing that
A lot of times they'll block like not.
like firewalls are an issue, like. So I'm on Cal Visitor right now, but like all the networks. Yeah, we should run.
Yeah, I'm not sure. Like,
It's only on local networks. Maybe we can like set up a hotspot or something.
Hey, I can't keep things that way.
Yeah, that again, that might be a school.
Are you gonna go over how to change this to PTP?
The what?
Are you gonna go over how to change this to PTP?
So it should not be hard. It should be just instead of having the
So we just
list.
change the client up to do something, and when we serve it.
So yeah, you can do two things, right? You can have a single client incorporate its own mini server and a client. So the server listens, and then the client like is outwards facing and sends messages. Or you can build it into one, call it like a P2P client that both listens and sends out messages, but that requires you to multi-thread because you need multiple things happening and not for it to be like sequential. Yeah, it would be blocking otherwise. And there's actually a very good module for that called Threads.
But we're not doing anything that's like finding the path to the client.
Yeah. So I mean, that is ideal. Like it's like trying to find a target client, and then like having like a recursive lookup where you're gonna like ping a guy, and then have them like ping their guys, like a DFS basically.
And we just hard code the lookup table.
There are like so many ways to do this. I wonder what the best way is. Because I was thinking just a DFS without a lookup table. So like every node stores the peers that they're connected to. And that's that's hard coded. Yeah. So maybe I should release some tests to like guide you guys. Yeah. Because there's like a lot of ways to do this, but
That makes sense. So it's gonna be fun.
Yeah, they're gonna do it on campus.
Hey, but you can charge me all of it a hotspot.
Yeah, does somebody, do you guys wanna like do a hotspot?
I'm gonna try with you 2 computers on.
Okay.
Yeah. We'll just try and connect.
Actually, I have a lot of gigs this so I'll see how many gigs.
I'm just gonna use all of it.
All the gigs. I'm on.
This shouldn't use too much,
Yeah, okay.
Yeah, what if these people back there is a hacker and they just
You use all of mine.
yeah, I'll tell you.
Yeah, so everyone has to enter that.
Yeah, it is the So right now, I think you have like connectivity. But in general, like
No, I was playing soccer like for time. Guys down.
Right, it's like for
It was not time for. Yeah, it's a little it's under there. It was a couple days ago.
So I think it's
Oh, really? Yeah, maybe it is.
Okay, also, if you guys want to sign in,
yeah.
Oh my god. That is so you. That's what he makes our.
what's up?
Yes, the thing is working. Yeah.
0606.
Oh, 06.
Oh, 06.